The truth is, my back is killing me. I don't know how long I can make it sitting in the chair, but it's early in the morning. It's like 7 a.m. and it's a good time to go over some things and learn something new and remember something that was already said and used. So I want to go back over this expression structure subchapter, which says we need a way to store S expressions as LVAL. This means we'll also need to store symbols and numbers. Again, what's an S expression? So what is an S? Uzun dinamai. What's the size? 18. Okay, what's an S expression? Okay. This means we'll also need to store symbols and numbers. We are going to add two new LVAL types to the enum. The first one is LVAL symbol, which we're going to use to represent operators, such as plus, okay. And the second new type is LVAL S expression, or SEXPR, which we're going to use to represent S expressions. So what do we have? We have enum, we have LVAL symbol, LVAL expression, okay. So what do we have? We have just a new enum, or actually it's the old same. The only difference is we have these two new values. Basically what I assume this enum does is it checks the current state of the LVAL object, of the LVAL structure, and it says, oh, okay, so it's either an error, we have a number, possibly a symbol, or an expression. As expressions are variable length list of other values. We can't create variable length structs. So we are going to need to use a pointer. We are going to create a pointer field cell, which points to a location where we store a list of LVAL. We are going to create a pointer field cell where we store a list of LVAL. Okay. Now this paragraph, I think, is worth understanding better. So we will have the LVAL struct, and inside it we'll have a pointer field cell, right? Which will point to a location where we store a list of LVAL pointers. More specifically, pointers to the other individual LVAL. Our field should therefore be a double pointer type LL pointer pointer. Just a second. Our field should therefore be a double pointer type. Why? Why? Okay. To represent symbols, we are going to use a string. Simple enough. We are also going to change the representation of errors to a string. Okay. What this means? This means we can store a unique error message rather than just an error code. Okay. This will make our reporting better and more flexible. Okay, this is just simple error reporting. I don't need this. I understand this. So this is the final struct. This is the final struct. Oh, okay. We have the type. I think this comes from an enum. We have the value, which is a long type. Now, these two error and symbol types have some string data. These are pointer because I think these are dynamically allocated, or their memory size is undefined and unknown. Count telling us how many LVAL elements we have. Now this double pointer dude. So this will be a list of other LVALs. So if we are gonna have one of them, he is defined and bounded by the size, by the dynamic size of the LVAL struct. But we will have a list of them, right? Is this a list? Yeah. So that's why we, oh shit, that's why we are using the double pointer. There's an old programming joke which says that you can rate C programmers by how many stars are on their pointers. As far as I know, a quadruple pointer has never been seen in the wild. Our new definition of LVAL needs to contain a reference to itself. This means we have to slightly change how it is defined. Before we open the curly brackets, we can put the name of the struct and then refer to this type inside the definition using struct LVAL. Okay. Okay, now the real question is, what is an expression? Okay, so as expressions are nothing more than just ways to represent data and code in Lisp-like programming languages. Simple enough. Eh. Okay. Other thing did I want to do? Yeah. Type def struct l1 struct l1 cell l1. Why is this struct defined like this? Why do we have two l1 definitions? Why do we use struct inside the body of the struct again? And how does the double pointer work? A lot of questions. Hopefully you'll get a lot of answers as well. Okay, the struct definition is part of a common pattern in C programming for creating a recursive. Okay, so I assumed it's something built in C. The typedef keyword allows you to create an alias for the struct L1, so you can refer to it simply as So okay, the type def keyword allows you to create an alias for the struct lol, so you can refer to it simply as lol without needing to write. Okay. The first lol, struct lol is the structure tag, and the second after closing the brace is the alias created by type def. And how the double pointer works? The double pointer, this guy is a pointer to a pointer, which allows you to create dynamic arrays of lol pointers, okay, where each lol can point to another lol. So this is just a way to represent serializable data, I think, in C. A pointer to a single lol structure, a pointer to a pointer, which can be used to represent an array of lol pointers. Each of these pointers can point to a different lol structure, enable you to store multiple. Okay. Okay, I think I have it. Can you explain the point one a bit clearer, please? In case our AI rise against us, you need to be nice to them. Okay, let me just stretch a bit. I'll be there in 20 seconds. I'm back. Okay. So the statement for the type def struct lol defines a struct lol. Struct lol is a structure tag. So this has a meaning behind it. This is the name of the struct type that you are defining. In C, when you define a struct, you typically give it a name. Known as the tag, which is used to refer to the structure type. The type def keyword allows you to create an okay. So this is the same as using a built-in type and the name of a variable. Only difference is, of course, we are using C, so we are creating a tag for this structure, and now this type def keyword is creating an alias for this, and it's gonna be called this, right? Okay. I still have no idea why we need to use, well, why we need to create a structure tag at all if you're going to use lol, but you know, maybe it's something that's built in C, which I'm not yet aware of. Struct lol, this is the tag name of the structure. This is the tag name of the structure. you want to refer to the structure type without using typedef, you would have to write struct verbal. Ah, okay, 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 okay. Okay. Album after typedef. This is the alias created by the typedef. With this alias, we can refer to the structure type simply as LL without the struct keyword. Okay. Okay, I understand it. I understand it pretty good now, actually. Okay, let's start another subsection. This one is called constructors and oops. And destructors. We can change our elval. Okay, construction functions to return pointers to an elval rather than one directly. Okay, this will make keeping track of elval variables easier. For this, we need to use malloc with the size of function to allocate enough space for the elval struct and then fill in the fields with relevant information using the arrow operator. So what does all of this mean? Just a second. We need to use malloc, which is the command for allocating size based on the type provided with size of function to allocate enough space for the elval struct. Okay. When we construct an elval, so oh god, I'm doing this badly. Elval. So when we construct this, its fields may contain pointers to other things that have been allocated on the heap. This means we need to be careful whenever we are finished with an elval. We also need to delete the things it points to on the heap. We will have to make a rule for ourselves. Whenever we free the memory allocated for an elval, we also free all the things it points to. Okay, a bit of garbage handling. Something that was quite common in C. So when we construct an elval, its fields may contain pointers to other things that have been allocated on the heap. Okay. I mean, all of this is still a bit foggy to me. I understand it. I understand it mostly, but it's still, you know, there's like a dimmed glass in front between me and all of this knowledge. When you construct an LL, it feels like pointers to other things that have been. Okay. Okay. How do I switch? Switch like this. Maybe where can I add these new methods? Maybe here. So okay, so this will return a dynamically allocated LL. It's gonna be a little num. We are providing a long value. Now, if this is a numeric value, can I do this? V allocate like this. So the type of this guy will be the number, and this will be X, and we are returning V. I think I have this above. I think I just need to remove it. Yeah. Yeah. How can I remove multiple lines? For DD 1, 2, 3, 4, 5, 6, 7. So 7 DD. Nice. Just delete one more. And so this is just another way of creating sorry, of creating the LL objects. I think I can do the same thing. The last one I followed the book, but I think I can do the same thing for the error, right? Yes. So what is the error type here? Just see. What is the error type? So it's a character. So what I'm gonna provide, because it can be dynamically allocated, I can provide a pointer to the error message, error, or maybe message only. Same thing as here. Allocate this. The type is error, and the error is, how can I assign the error? C is an old programming languages, so it probably does something weird. Yeah, as I guessed it. So I, I took a look of the code snippet in the book. So I assigned how much size here. No, not the size of. I assign the length of the error plus 1 for the null character, right? Then I copy this into M and then return V. Okay. Let's do the same for the symbol. I think I can now remove also this method here, which is the old implementation of the constructor. Okay, so I can probably delete this 1, 2, 3. Okay. L. Fuck. Symbol. This is supposed to be a pointer. Let me just stretch again my back. Ah, my back just got stiff. Okay. What do we have? We have the LL symbol. I think for this we can just copy all of this, but how do I? Is it like no? It's like yank, and then here I do paste, right? Yes. Here as well. Not here, but yeah, fuck me. So another, can I do 2 yanks? 3 lines yanked, okay. And now if I do paste, okay. I have this here, I don't need this. I'll change this to a symbol. I'll change this as well to the variable name, the proper variable name. I'll put this here. Okay. Same thing. Let's, how many lines do I have? I have 7. Oops. Fuck. Okay, 7 lines yanked. I can paste them here. Nice. And this guy will be a sex expression. A nest expression. Void. S expression. We're gonna set 0 to the count. We're gonna set the cell to be null. Okay, that's it. So what's null? Null is a special constant that points to memory location 0. In many places it's used as a convention to signify some non-value or empty data. Above, we use it to specify that we have a data pointer, but that it doesn't point to any number of data items. You will see null crop up a lot more later. Okay, null is a common construct among many programming languages. It just signifies a lack of value. It's a limbo, programming limbo. Why are you using a string length +1? Because of the null terminated characters. Yes, this means that the final character is always a 0 character. Okay, we have another code snippet. We now need a special function to delete lval. This should call free on the pointer itself to release the memory acquired from malloc. Wait, I don't want to look at this. Okay. So let's analyze this paragraph line by line, word by word. We now need a special function to delete lvals. Okay, so we'll have a new function. This should call free on the pointer itself to release the memory acquired from malloc, but more importantly, it should inspect the type of the lval. So is this working? Okay, if lval type equals this is pseudocode. I'm just thinking about this loudly. What lval error? I don't know. Let's say error. We do one form of handling. Otherwise, if we have lval, I don't know, number, we will have another form of freeing the size. We are only freeing the pointer values, it seems. Okay, simple enough. Okay, ladies and gentlemen, I'm really sorry. I need to stop it here. It's quite early still, but my back's being stiff the whole morning. I need to stop. I'll do another stream later today. So thank you all for watching and see you in the next one, which will be later, I promise.